Earth's fury, unveiling supervolcanoes. Yo, science enthusiasts, buckle up for a fiery dive into the Earth's core, where colossal beasts slumber, supervolcanoes. Imagine a massive pot of molten rock simmering for millennia. This scorching liquid, called magma, builds up in vast underground chambers for hundreds of thousands of years. The pressure intensifies, the Earth groans, and then, with a force that dwarfs our mightiest weapons, the supervolcano erupts. Volcanoes come in all shapes and sizes, but most are fueled by two main sources: tectonic plates and mantle plumes. Tectonic plates, Earth's giant jigsaw puzzle pieces, constantly grind against each other. When they collide, one gets shoved beneath the other, melting under the intense heat. This molten rock, seeking escape, can rise as magma, feeding volcanoes. Mysterious columns of scorching hot rock, called mantle plumes, rise from deep within the Earth, punching through the crust to form volcanoes in unexpected locations. To measure an eruption's explosive power, scientists use the Volcanic Explosivity Index, VEI. Similar to the Richter scale for earthquakes, VEI ranks eruptions based on ejected material. A VEI-2 eruption might fill a few Olympic pools with lava, while a VEI-5 eruption, like the recent Hunga Tonga Hunga Hahapai, can trigger global tsunamis and send shockwaves circling the Earth. But the real monsters lurk at the top of the VEI scale. A VEI-6 eruption, like Krakatoa in 1883, can reshape the world with a sound heard globally, monstrous tsunamis, and enough ash to dim the sun for years. VEI-7 eruptions are history-defining catastrophes. In 1815, Mount Tambora unleashed a volcanic winter that caused widespread famine. Thankfully, these occur only a handful of times in human history. So, what exactly is a supervolcano? The term is more media hype than scientific fact. The key distinction is that not every eruption from a supervolcano is a super-eruption. What makes them truly frightening is their potential for unimaginable power. Imagine an explosion 1,000 times bigger than the largest nuclear bomb, spewing billions of tons of ash and gas into the atmosphere. This is the raw power of a super-eruption, capable of impacting every corner of the globe. These eruptions leave behind massive calderas, vast depressions formed as the ground collapses after being emptied of magma. But unlike their smaller cousins, supervolcanoes can take hundreds of thousands of years to Estimates suggest a super-eruption could occur every 17,000 years, a sobering reminder of their potential threat. The Oruanui eruption in New Zealand 26,500 years ago serves as a stark example. This eruption reshaped the landscape and triggered a period of abrupt cooling in the southern hemisphere. However, the 74,000-year-old Lake Toba eruption was a true turning point. It unleashed enough ash to blanket parts of South Asia and triggered a global temperature drop of 4 degrees Celsius. A volcanic winter may have gripped the Earth for a decade, followed by centuries of drought. The largest volcanic events weren't even explosions. The Siberian traps, 250 million years ago, were a continuous release of lava that lasted for millions of years, raising ocean temperatures and causing a mass extinction. Thankfully, such cataclysmic events are a thing of the distant past. Should we fear supervolcanoes? While they deserve respect, the media often paints an exaggerated picture of impending doom. The most famous supervolcano, Yellowstone, will erupt again, but most likely with a whimper, not a bang. These eruptions, while destructive, are unlikely to threaten humanity. The chance of a world-ending VCI-8 eruption in the next few hundred years is very low. Additionally, these events wouldn't come as a complete surprise. Scientists can monitor changes in magma chambers, providing valuable early warnings. This precious time could be used to evacuate vulnerable areas and develop solutions to mitigate the climate disruption caused by volcanic ash. The future holds promise. Imagine technology allowing us to remove sulfur and ash from the stratosphere, essentially eliminating the root cause of the climate chaos seen in past eruptions. Perhaps we can even harness the immense geothermal energy stored within these fiery giants for good. Just like with other natural disasters, we're constantly improving our ability to predict, prepare for, and respond to volcanic threats. Decades ago, sending a probe to redirect an asteroid was science fiction. Today, it's a reality. With determination and innovation, humanity can face even the most daunting challenges.